Hi students, in previous lecture we started the quadratic equations. In that lecture we learned what is a quadratic equation, what is the difference between the roots and solution of a quadratic equation, and the roots of the quadratic equation ax square plus bx plus c equals to 0. The roots we obtained it as x is equals to minus b plus or minus square root of b square minus 4ac by 2a. Then depending on the discriminant b square minus 4ac, the nature of the roots we learned. In this lecture, we are going to learn about the relationship between the coefficients of the quadratic equation and the roots of the quadratic equation. Okay, so consider a quadratic equation, a general quadratic equation ax square plus bx plus c equals to 0. Okay, which is a quadratic equation, and having the roots we obtain it is as x is equals to the two roots minus b plus or minus square root of b square minus 4ac by 2a. Okay, if this quadratic equation having the root size alpha and beta, the two different roots, then we can write alpha equals to minus b plus square root of b square minus 4ac by 2a, and another root as beta, which is equals to minus b minus square root of b square minus 4ac by 2a. Okay, so these are the roots. Okay, if we add these two roots, that means alpha plus beta. Okay, if we add these two roots, what we'll get over here? Then we can write it as minus b plus square root of b square minus 4ac by 2a. Okay, directly I'm writing it as minus b minus square root of b square minus 4ac by 2a. Okay, so this discriminant will be square root of discriminant or cancelled out, and we can write it as minus b minus 2b by 2a, and which is equals to minus b by a. Okay, then the alpha is one root and beta is another root for the quadratic expression ax square plus bx plus c equals to 0. We assumed as the two root size, one is alpha, another root is as beta. If we add these two roots, that means sum of roots. Okay, which is sum of roots. Okay, the sum of roots we are obtaining it is as minus b by a. So where the minus b is called as, so minus of b is called as the coefficient of x. Okay, here b is called as a coefficient of x, and a is called as a coefficient of x square. Okay, coefficient of x square is a. Okay, then we can write it as the sum of roots in a quadratic equation. The sum of roots in a quadratic equation is alpha plus beta. In terms of the coefficients, we can write it as minus coefficient of x by the coefficient of x square. Okay, then we'll obtain the sum of the roots of the quadratic equation. Okay, now if we multiply these roots, okay, then we have as alpha equals to minus b plus square root of b square minus 4ac is by 2a is alpha, and what is beta? Beta equals to minus b minus square root of b square minus 4ac by 2a is beta. If we multiply these two, alpha into beta, then what we'll get? which is in the form of minus b by 2a as a one term. In the two cases, minus b by 2a as a one term, and another term is square root of b square minus 4ac by 2a is another term. Okay, square root of b square minus 4ac by 2a is another term. Now which in the form of, so this term some x plus y into now x minus y. Okay, so alpha into beta is in the term of x plus y into x minus y. Then we will get it as x plus y into x minus y as x square minus y square. Then we can write it as x square minus y square. What is x square? So minus b by 2a whole square minus y square. What is y square? B square minus 4ac square root of b square minus 4ac by 2a whole square is the y square. Okay. Now in the denominator we will obtain it as 4a square as a denominator 4a square. Then if we can add the numerators, what is minus b whole square equals to b square minus of, and what will get square root and square will be cancelled out. We can write it as b square minus 4ac, and which is equals to b square minus b square plus 4ac by 4a square. Then finally we are obtaining here it is as 4ac by 4a square, 4a and a. Finally what we are getting? The alpha into beta equals to c by a. And what is c? Coefficient of x power 0, nothing but constant term. Okay, c is nothing but constant term. X power 0 term is called as a constant term by coefficient of x square. Okay, coefficient of x square. Okay, now we can write what is alpha multiplied by beta. Then we can say that which is the product of roots, which is the product of roots. Okay, the product of roots can be written as alpha beta. So the alpha beta is nothing but c by a. So in the ax square plus bx plus c equals to 0, the product of the roots can be written as c by a. Okay, we obtained as the sum of the roots alpha plus beta equals to minus x coefficient by x square coefficient minus b by a, and alpha beta equals to constant term by x square coefficient. In these two cases, the condition it has to be satisfied as a not equals to 0. Then only we consider the quadratic equation. Okay, now consider the quadratic equation. What we assumed, ax square plus bx plus c equals to 0. If a is taken as a common, then we can write it as x square plus b by a into x plus c by a equals to 0. So which can be written as a times of, now x square, then b by a can be written as plus b by a can be written minus of minus b by a times of x. Minus into minus it will be plus, then we obtain it is as equals to 0. Okay, now nothing is changed. Okay, so in this one, a times of x square, okay, minus of a times of x square minus of, and what is this minus b by a? Minus b by a can be written as what it is, alpha plus beta. Okay, minus b by a can be written as alpha plus beta into x. Okay, plus, and c by a can be written as alpha beta. Okay, c by a can be written as alpha beta equals to 0. Okay, then a quadratic equation ax square plus bx plus c is also be written as some a times of x square minus of sum of the roots plus product of the roots, and which is also be written as a into what it is, x minus alpha into x minus beta equals to 0, which is also be written as a times of x minus alpha into x minus. If we expand this x minus alpha into x minus beta, we will get it as x square minus of alpha plus beta times of x plus alpha beta. So now the quadratic equation, any quadratic equation can be written as, if we know the roots. Okay, so for example, we are having a quadratic equation x square plus 5x plus 6 equals to 0. If we find this, we obtain the roots as x is equals to minus 2 and x is equals to minus 3. Okay, x is equals to minus 2 and x is equals to minus 3. And here the a equals to 1. Then the same thing can be written as a into 1 into x minus alpha. So alpha is minus 2. So what it is? X plus 2 into x plus 3. Okay, the same thing can be written as x plus 2 into x plus 3. Otherwise, which can be written as x minus x square minus of 2 plus 3. Okay, x square minus of minus 2 minus 3 into x plus minus 2 into minus 3 equals to 0. Again, we will get it as, which is in the form of x square minus of alpha plus beta into x plus alpha beta. Okay, where alpha equals to minus 2 and beta equals to minus 3. And again, we will get the result as x square plus 5x plus 6 equals to 0. Okay, so now in this one, we obtain the quadratic equations ax square plus bx plus c. The roots, sum of the roots is minus b by a, and product of the roots is plus c by a. Okay. Okay. Now ax square plus bx plus c equals to 0. If a is equals to 1, what happens? If a is equals to 1, then we can write it as x square plus bx plus c equals to 0. In this case, what is the alpha plus beta? Sum of the roots equals to minus coefficient of x. What is the coefficient of x? Is b, and coefficient of x square, here it is 1, simply nothing but minus b. And if alpha beta, the product of the roots is nothing but c by a, constant term, by coefficient of x square, here a is equals to 1, simply nothing but c. That means if the coefficient of x square is 1, we can directly write it as the sum of the roots is minus of the coefficient of x, minus of the coefficient of x, and the product of the roots is the constant term itself. Okay, let me understand this with one example. Now we are considering x square plus 4x plus 4 equals to 0 is a quadratic equation. Here a is equals to 1. Okay, here we are obtaining it as a is equals to 1. Given that a is equals to 1, then what is the sum of the roots? Alpha plus beta simply can be written as minus of the coefficient of x, simply it is minus 4, and the product of the roots is simply nothing but it is only the constant term 4 only. Okay, so if ax square, so what it is, if the constant term, if the x square plus bx plus c, if the x square coefficient is 1, then we'll obtain direct, we can write directly as the sum of the root size minus of the x coefficient and product of the root is the constant itself. So that's why it is better to represent any quadratic equation as the coefficient of x square as 1, then we can directly write the required solutions. Okay, now we will try to solve few questions from the basics of the quadratic equations what we learned. Okay, the question is, find all k such that the equation x square plus 2 times of k plus 2 of x plus 9k equals to 0 has equal roots. Okay, has equal roots. Okay, right. So any quadratic equation x square plus x plus c, whatever it is, the quadratic equation will have two roots. Okay, let we are considering that x square plus bx plus c equals to 0 is having the two roots. Let the two roots, we are assuming it is as alpha and beta. Then what is alpha plus beta equals to minus b by a. Alpha beta equals to c by a. Sum of the root size minus b by a, product of the root size c by a. Okay, and here asking us find the all possible values of k. Okay, and what he has given, if the roots are equal. So roots are equal if any quadratic equation, then the roots are equal. The nature of the roots is given as equal. When the roots are said to be equal, if the discriminant is equals to 0. If the discriminant is equals to 0 in any quadratic equation, we can say that the roots are real and equal. Okay, that means this question is based on the nature of the quadratic equations. So that means nature of roots of the quadratic equation. Now we know that discriminant can be written as b square minus 4ac, which is equals to 0. The roots are equal means b square minus 4ac has to be equals to 0. Now compare with the general quadratic equation. So x square, ax square, that means here a equals to 1. Okay, now compare these two. Okay, then we will get it as a equals to 1 and b equals to 2 times of k plus 2. Okay, which is as b equals to 2 times of k plus 2 and c equals to 9k. Okay, just simply substitute over here. Okay, if we substitute b square minus 4ac equals to 0, then 2 into k plus 2 whole square minus 4 into a is 1 and c is 9 times of k equals to 0. Now what it is, 2 square, 4 times of k plus 2 whole square minus 4 into 9k equals to 0. And if we take 4 as a common, then we can write it as k plus 2 whole square minus 9k equals to 0. Then if we simplify, what we'll get, k square plus 4k plus 4 minus 9k equals to 0. Then we will obtain as k square minus 5k plus 4 equals to 0. Now he is asking us to find the values of k. That means if we simplify this quadratic equation in k, then we will get the k values. How to simplify this? K square minus 5k plus 4 equals to 0, and which can be written as k square. And what is the sum of the roots? We can written as k square minus k minus 4k plus 4 equals to 0. Then we can write as in terms of x minus alpha into x minus beta. So k minus alpha into k minus 4 equals to 0. Then we will get k equals to 1 and k equals to 4. Now what are the possible values of k for the given quadratic equation? Okay, the possible values of k, the given quadratic equation, find what it is k values. K has to be k is equals to 1 and k is equals to 4. Question is, show that the roots of the equation x square minus 2px plus p square minus q square plus 2qr minus r square equals to 0 are rational. Okay, what he has given in the question, the roots of the equation are rational. Again, it is based on the concept of nature of the roots of the quadratic equation. So when the roots are said to be a rational roots. Okay, just recall the concept. When the roots are said to be a rational roots, whenever the discriminant is expressed as a perfect square. Okay, if the discriminant is expressed as a perfect square, then we can say that the roots are rational. Okay, just watch the video of the what quadratic equations introduction. Okay, I am leaving in the cards. Watch this video, then you can able to know that identify the roots are rational if the discriminant is expressed as a perfect square. Okay, now if we compare here with the ax square plus bx plus c, now this total term is constant. Okay, then what is b here? B is nothing but minus 2p, A is equals to 1, and this total term is C. Now discriminant B square minus 4AC. Okay, now we are finding the discriminant B square minus 4AC. What is B? Minus 2p whole square minus 4a is 1 into C. P square minus q square plus 2qr minus r square. Okay, minus r square. So which can be written as 4p square. Okay, minus of, if we simplify this, minus 4p square plus 4q square, and we'll get over here minus 8q, or minus into minus plus, we can write it as 4r square. Now the 4p square and 4p square will be cancelled out. If we take 4 common from this one, we can write it as q square minus 2qr plus r square. Okay, which is in the form of a square minus 2ab plus b square. Then we can write as 4 into what it is, q minus r whole square, and which is can be written as 2 into q minus r whole square, sorry, 2 into q minus r whole square. Then 2 square is 4, q minus r square. So that means now the discriminant is expressed as a perfect square. So then we can say that the roots of this equation are rational. Okay, now another question. If alpha and beta are the roots of the equation ax square plus bx plus c equals to 0, directly first whenever you are reading this sentence, directly write it as ax square plus bx plus c equals to 0. Alpha and beta are the two roots of this one. Then we can write it as alpha plus beta equals to minus b by a, alpha beta equals to c by a. Okay, that is the known thing to us about the quadratic expression ax square plus bx plus c is equals to 0, having the alpha and beta are the roots. Okay, form a quadratic equation whose roots are, now asking us form a quadratic equation. Now we need to form a quadratic equation whose roots are p alpha and p beta. Okay, so we know that if alpha and beta are the roots of a quadratic equation, we can write which is as, okay, which is as a times of x minus alpha into x minus beta. Okay, which is the way of writing the quadratic equation. Okay, and asking us to find, okay, asking us to find the p alpha and p beta. P alpha and p beta are the roots of another quadratic equation. Then we can write it as let's consider here, we can write as x minus alpha, means here p alpha into x minus p beta equals to 0. X minus p alpha into x minus p beta equals to 0, which can be written as, so the same thing can be written as here x square minus of alpha plus beta into x plus alpha beta. Okay, the quadratic equation can be written as x square minus of sum of the roots, what is p alpha plus p beta into x, okay, plus product of the roots p alpha into p beta equals to 0. Okay, he has given the roots of the quadratic equation and asking us to form the quadratic equation. Now we are forming the quadratic equation. If the roots are known, we can write the quadratic equation as x minus alpha into x minus beta equals to 0. Otherwise, x square minus of alpha plus beta into x plus alpha beta equals to 0. Now we are writing over here. Then x square minus of, we can take p as a common from this one. Okay, let we are taking p as a common. Then we can write as alpha plus beta times of x, the next p square times of alpha beta equals to 0. Now he has given the first statement if of alpha beta. If a condition is given, if means condition. Now we need to use this condition in the next statement. Okay, this condition has to be used in the next statement. What is the next statement? Whatever the quadratic equation we are forming. Okay, x square minus p times of, what is alpha plus beta? We can write as minus b by a into x plus p square times of, and what is alpha beta? Simply it is c by a equals to 0. Okay, now if we cross multiply the a, then what we'll get? Finally we get it as ax square and minus into minus plus pbx plus p square c equals to 0, which is our required quadratic equation whose roots are p times of alpha into p times of beta. I think now you are able to understand how to solve the basic problems of the quadratic equations. If the nature of the quadratic equations is given and if the roots of the quadratic equation is given, so now this is the way of finding the solutions of the from the basics of the quadratic equation. Thank you.